right, so these problems are exponential functions that we are dealing with. And so we're going to start with a nice simple one just to see how they work. So here is our exponential function, and it says that x is the number of years after 1995. So we want to write out what they represent. So x equals number of years after 1995. And so our A here is the number of alternative fuel vehicles sold in a given year. So number of vehicles sold in a given year. So what that means is if we plug in a year, it tells us how many vehicles were sold that year. And X is the number of years after 1995. So if you were to plug in 0, it would tell us the number of years. So that means 246,855 alternative fuel vehicles were sold in 1995. And so it's asking us to find 2000, 2013, and 2018. And they're asked differently so you can see it. It says find the number of alternative fuel vehicles sold in 2000 and 2013. And they will also ask things like then project the number of alternative vehicles sold in 2018 or 2024. So these are all estimates because we're giving an exponential model here that models the function. It's not exact, but it should be close. It could be exact, but probably not. All right, so to find this, all you have to do is subtract the first year. So that would be 5. That would be 18. And that would be 23. And then we're just going to substitute them in. So A of 5 would be 2000. A of 18 is the year 2013, and A of 23 is that year. So you can do it this way where we just plug the numbers in. What we're going to be using is our TI 84, our calculator. You can also use Desmos for this as well. So we're going to find each of these values in our calculator. So from our y screen, so click on y equals, we do 246, 855, parenthesis, 1.0931, parenthesis, and then we put an x up there. That's not putting the x. Scroll back, delete. You want to hit the caret key right here to get the exponent and then x. And so then we have our 246,855 and 1.0931 to the power of x. Now we're going to hit our window here and we're going to put in there realistic values, so 0. And if we go back to our notes, you can see we need to go all the way up to 23 or more. So we're going to start with 0, which is 1995, and then we're going to go up to 25 just to get a nice picture. So our x here will be 25. So now we're going to have the year from 1995 all the way up to the year, 2020. Now we just have to hit zoom 0. Remember, zoom 0 fits it, and it's going to give us our exponential graph. So this is the year at 1995. So that would be the 240 some thousand. And you can see the number of cars sold is growing exponentially. So now we just need to find each of them. So we're going to take each of our x's and we're going to plug them in. Plug in 5, 18, and 23. So to do that, we do trace and then 5 and hit enter. And we get 385,248.89. So what is that? 385, we'll just round this up to 9. So 385,249. So 385,249 vehicles. And we'll go back now, we do trace 18. And that says, now we're in the millions. So 1.2, so 1,225,519. So 122,551. So 122,5519. There we go. vehicles. And then one more left, that's 23. 5519. All right, and then now the last one, 23. So trace and 23, and it says 1912580. So 1,912,580. So 1,900. So 1,912,580. So 912,580 vehicles. So it tells us each of these values just by doing trace on there. And so you hit trace, enter, and it'll give you all the values a lot cleaner and a lot quicker. You can also use the table function. So if you go second table set, we started at 0 with a change in table of 1, and then table, you can then find them as well. So there's 5, and then scrolling down, would give you the other values. One more. So there's the 18. And see, it's not giving us exact. Okay, so let's try this again. Let's do the exact same thing. So it says the value of a Porsche 993 Techheart T years after its purchase. So T equals years after purchase is given by this function. So we don't know our initial year. It could be purchased in 1996 or 1997. We don't really know, 1998. But we're just saying that this is the number of years after purchase. This is 10 years after it. So that would be like 2008 if it was purchased in 1998. Okay, so what we're going to do is graph the function. And by that, we're going to create a table and then plot them here. So we're going to plug this in our calculator just like we did before. But this time we're going to pull out some table values. Okay, so that was 100,000. Parenthesis 0.89 exponent x. And then the window, again, we want the first 10 years. So we're going to go 0, 10. And then I like to graph it just to get the picture to make sure I did plug in an exponential function. It also allows you to see it. So you can see here we're dealing with a decay function because that's 0.89. So it's 89% of the value each year. It's depreciating. So now we're going to go back to our table. Started at 0. Go second. And if you notice on there, our change in table was 2. You'll see that when we go back. And then hit second table. And so we're going to then copy these values over. So 100,000, obviously. And then 79,210. So 100,000 and 79,210. And we just keep going back and forth and copying them. So you're going to copy them all over. So that would be 62,742, 49,698, and then for 8 it was 39,366. So you can see our change in table for our t was a factor of 2, or there we go, a difference of 2, and so it's increased by 2, and you can see our values going down. Now you just need to plot them and get a nice rough sketch. So you could see the 10,000 here is the bottom of the line. So that would be 100,000 and then 79,000. So it's right about, let's go a little bit below. It's not exactly 80 right there. And then 62,000. So a little bit above. And then 49. Oops, I got to move over. 2. At 2, it's 79. And then at 4, it's 62. And then at 6, it's 49. And then at 8, it's 39. So right there, so you can see there is our decay. All right, so it says here, use the graph to estimate the half-life now. So half-life just means it got cut in half. And so if you look at our initial value, we started at 100,000. Let's try that color a little different here. At 100,000. So when does it become half? So half of 100 would be 50. So right here. That's our half-life. So this right here is our half-life. So 6 years. So t equals 6 years is the half-life. That means that every 6 years, the value of this car will be cut in half. So in 12 years, we would estimate that to be worth $25,000. So when will the car be worth $25,000? 12 years later. And that's it. So you can plug these numbers in and you can actually see when something gets cut in half. That's the half-life. You could even come up here and look for the doubling rate. So if we had our 246, once you find out when it becomes 500,000, that's how often it will double. All right, thank you.